Okay, so let's take an example. If this is a wire and the current is flowing like this, right? So how the current flow? If the current is flowing like this, okay? So in which direction would be the magnetic field at the center? Think about it. So what you have to do, you have to see if the current is going like this, you have to see where would this particular element of current create the magnetic field. How would you do it? You've got right hand thumb rule. So align the thumb to the current, direction of current, and see center pe where is the direction. So this is the direction inside, right? Similarly idhar ja raha hoga. So again this is the direction, idhar ja raha hoga, this is the direction, which means that this is how the magnetic field is going to be created. And this is how, if the magnetic field is going to be created, this face of this circular conductor is going to be north, and this face is going to be south, right? So north and this is south. All right, so this is how you figure out which face is going to be north and south. And if I reduce the radius, so what happens now? It has taken 2 turns, right? And the radius is also reduced. So now will the magnetic field increase at the center or decrease? Think about it. Of course it will increase because the distance has reduced 1. So because of reduced distance, the one current carrying element is going to create more magnetic field here because the distance has reduced. Second, now there are 2 turns of current. So instead of 1 current, now there are 2 currents flowing here, because of which the magnetic field will be created. So here now the magnetic field would have increased. And what if I make multiple turns like this? Multiple turns. So then what would happen is that it would create even more magnetic field at the center, and this particular construction is called solenoid. All right. So what happens is that there are multiple turns in a solenoid and current is carried through it. Of course it has to be insulated, otherwise what will happen is that when you make a solenoid like this, instead of the current flowing in circle, it may just flow like this, right? So with an insulated wire it is created, and multiple turns are created so that the magnetic field at the center is very, very strong, and you can figure out which side is going to be north, which side is going to be south, based on which direction is the magnetic field being created. All right, so where is solenoid used? Of course it is used as electromagnet. So if you put on the current, it becomes a magnet. If you switch off the current, the magnetism goes away because now there is no magnetic field. All right, so that's solenoid. And the same thing holds in solenoid also. If the radius is less, the magnetic field at the center will be more. If the current flowing is more in the solenoid, then of course the magnetic field at the center will be more. And if there are more turns per unit length, so whatever, if in 1 meter you have more turns, right? So magnetic field will be more or less? It will be more, because there are more current flowing per unit length, right? So yeah, these are the things on which magnetic field intensity for a solenoid depends.